A screw presence sensor is simply an inductive high-resolution ring sensor that the feed tube goes through. The purpose of this sensor is to let the PLC know that a screw has fed through and has reached the nose piece and is ready to drive. We recommend one sensor at the nose piece and one sensor at the exit of the feed unit.
Track sensor controlling.
This is a key feature of the SA1.5, SA2.5, or the SA3 feed unit. Track level sensing. As you can see from the video clip, the track level sensors are mounted on and look across the top of the track. This sensor controls when the bowl starts and stops. When the track is full, the bowl stops. As the screws are fed and the track empties, the bowl will start. The purpose of this sensor is to prevent excess back pressure in the track that will cause jams. This option is needed for screws that are difficult to feed. Nothing is worse than a screw feeder that constantly jams and causes downtime. The 9-pin connector is the interface for PLC control. You will receive a schematic with pin-out assignments. For example, pin 1 is 24 VDC in. Pin 2 is screw feed metering signal input. Pin 3 is screw feed metering signal output, just to name a few. Screw bowl level sensor used to provide a signal to the PLC for the purpose of indicating a screw low level in the bowl of your feeder. You can adjust the sensor at a desired minimal level in order to fill bowl in a production environment. Separate feed blow is a control option for all of the assembly automation feed units. This option gives the customer complete control of the valves in the feed system. Valve number 1 is a double pilot solenoid valve that moves the screw from the drop-off position to the pickup position, then back to the drop-off position. Valve number 2 blows the screw down the feed hose to the nose piece. These valves are all 24 VDC. The main advantage of this option is the ability to purge the system of all screws in the feed hose without adding any more screws. This is our step-down transformer. It will step down from 220 VAC to 110 VAC. We use this on all of our CE machines that we ship to Europe. Screw selector used to feed screws of similar characteristics from 2 feed unit into a single or multi-head driving systems. Screw diverter used to feed screw from a feed unit into a twin or a multi-head driving system sequentially. High-cycle screw diverter used to feed screw from a feed unit into a twin or a multi-head driving system simultaneously. This customer has 2 screw sizes, but only one part. The only difference between each screw is the overall length. So we use 2 feed units, 1 for each screw size. 1 screw selector, 1 3-position diverter, and 1 2-position diverter. With this setup, we are able to select the correct size screw and feed 4 screws to a 4-spindle screwdriver slide. This system feeds a double-ended stud. The drive end of this stud is longer and heavier. Because of this, the stud feeds with the drive end pointing down. To solve this problem, we used our inverter assembly. The stud feeds into the inverter assembly drive end facing down. Then we shift the block over and blow the screw back out the top of the inverter assembly to the nose piece, and now the drive end of the stud is pointing up and ready to drive.
Screw presenter. This video features the Assembly Automation's pick and place system or screw presenter. We use the pick and place system for parts with difficult screw driving access. Occasionally we come across an application that has difficult screw driving access as well as a screw that is difficult to feed. A big advantage to blow feeding to the pickup nest is that you can have the pickup nest close to the screw driving locations. On large parts you have the option of having multiple pickup nests around the part. This will eliminate the travel time to and from the pickup point.